Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. The aim of today's topic is becoming aware of how to design stochastic lattice structure within a given body. Okay, here we are focusing on first selecting the particular body, and then generating the stochastic lattice structure within that given volume. Okay, here there are some important things we must know. They are point generation, and then random point, the spacing between the points, and the number of points we want, and the point spacing. So these are the some input parameters we have to mention here. Okay, so let's start designing. I will explain you one by one. So be there. So first we can give the name of the file as stochastic stochastic volume lattice. Okay, and we can add the description as the design of stochastic volume lattice. Okay, this is our description, and very important thing is that we must give the section name. So that is as stochastic volume lattice. Okay, this is all about. So here first we must know from where we can get the stochastic lattice. So it is already existed within the nTopology software. I will show you how to get it and how to use it in the right way, so that we can be able to generate the stochastic lattice structure. Okay, so there are so many ways, so many means there are two ways to get the stochastic value. One is directly search from here. If you want to know if you know the term or its keyword, you can directly search from here, or you can either you can go to the lattices tab, and from here we can be able to get the stochastic lattice structure. Here there is a one particular section for generating the stochastic lattice structures. Okay, so from here what do we observe? There are various types of stochastic lattice structures. So one is like Voronoi surface lattice, Voronoi volume lattice. So there is a difference between two. One is the Voronoi generated on a particular surface of a given body, either cube. If it is a cube, then we can get the Voronoi only on the faces. If it is cylinder, it will generate the Voronoi with respect to the surface area. Okay, and then what about the volume lattice? So today we are going to use this, and we are able to generate the Voronoi stochastic porous structures. Okay, so I think it is not a lattice structure. We have to call it as a porous structure. Why? Because lattice one we can say that periodic. If it is a periodic lattice, then we can call it as a periodic lattice, but I think there is a difference. So we can consider that as a porous structures. Okay, porous Voronoi porous structure. So let's select this. So what do we observe here? We have to define three input parameters, input geometrical parameters. What are they? They are seed points we need to define, and thickness of a given geometry, given lattice, and the boundary we need to define. So what is seed points? So in to generate Voronoi, so we have to define some points. We have to define some points within the body. So with respect to that point, one volume, one volume will be generated with the boundary, and within that boundary, suppose if you know the mesh element, tetrahedral mesh or cubical quad mesh, so similar type of that. So we have to define some points within our given body means it can be cube, it can be cylinder, it can be cone, it can be like sphere, or it can be any random torus or anything. Body can be anything within the given body, and within the boundary of body we are distributing the some points. So considering this point, we are able to generate our particular Voronoi lattice structure. Okay, and then thickness. So once we have given the particular point, then we need to define the thickness of particular unit cell. particular unit cell means it is not yeah, it is a random unit cell shape. There is no any definite particular shape. I will explain you. I will explain. So let's double click here, and as I said, we can also get it the Voronoi. I told you that you must know name of that particular block. So its name is like Voronoi. So if you see this, we can get it from here. So that's why I'm telling you. So you have to practice it daily, and then only you can able to get their particular name, and find once you know the term, and you can try for searching that particular tab where it is exactly available. So I have deleted that. Now let's move on here. What is seed point? If you double click here, if we double click here, what do we observe? We observe that there are different parameters we have to select. So in today's lecture, we are going to select a particular body, and within that particular body we are defining some points. So can we find that? Yes, definitely. So like here, what do we observe? Equidistant point curve, filter points by volume, and import points. If somebody already have the point, they can import it, or project points to the plane. There is a plane, and within that plane you can project the points, random points in body. Yes, in today's lecture we are going to select this particular option, and there are other options as well. So let's select this particular one. And here again, what do we observe? We have to define again three parameters. One is like a body, type of body we are going to use. As I said, it can be cylinder, cube, like sphere, and or any other random shape. It is up to you. Okay, so it can be anything. Now let's select the body. We can select the body from create tab. Here, if you go to the primitive, you can select any one of this body, volume body, or you can create your by own. So let's select the cube. So yeah, we can place this cube and make it as a variable. So later on we can use this cube. Okay, here cube has a defined center point, and its size is like 10 mm, 10 mm, 10 mm. Okay, if you want to vary it, you can vary it. It is up to you. You can change the value simply. So let's place this within the body. We have placed it. Due to it, we made it as a variable. It will be here only, and we can use it again and again. And now we have defined the body, or we have defined our particular body as a cube. And later on we can move to point spacing. Yeah, this is very important factor, and it will influence more on the particular geometry. So point spacing means if we are selecting the 4 points within the cube, then we need to define the what is the distance between each of the points. So for suppose if we can give from higher value, we must come from higher to lower value. So for suppose we can take the 5. Suppose let's minimize this. Yeah, what do we observe here? We have given point spacing as 5, and if you further increase the value 8, so the point spacing, like number of points, got reduced within our like cube. Okay, so this is our cube, and the number of points got reduced, and the lattice can generate with respect to that point, considering the center point. Okay, so this random seed, it doesn't have that much influence. I hope. So let's enter the 112. So still it doesn't have that much effect. It is like you can place the particular point spacing. So as I said, this point spacing has a much more effect. So it will keep it as it is. If you want to change somewhere some other distance, some other place, you want to place the points like randomly, like you can use this. So this is how you can consider this. So what I suggest, you can just keep it as it is, don't change. The most important factor, as I said, point spacing. If you give the one, so let's see what is going to see. The point spacing is only 1 mm between each of the point. So that's why we have got too many points within the given like a volume. So this is our volume body, and there are some points, there are some points on the surface and within the volume as well. So let's move on. Now we have defined our body and point spacing, then random point. The let's minimize this tab. Now what do we need to define? Till now, we have defined seed points. Then two factors remain left. One is optional, that is boundary digit. I will show you what exactly it means. So before that, let's minimize this, and we can make our point spacing as 3 for time being. And let's give the thickness. Let us give the thickness. Let's minimize this, and we can give the thickness as like zero point 0.5. Okay, zero point 0.5 mm. And now it started generating the particular Voronoi lattice. I will show you what is going to happen. Yeah, this is our particular Voronoi lattice with respect to our given points and given body. So I hope you understood till now. So now there is a one more parameter is left. What is that? Boundary. As in topology, by default it is suggesting that it is optional, but you have to utilize that. Why? Because what do we observe here? There are some links, they are free, isn't it? They are free, they are not connected. They are not connected. If you want to connect them, if you want to connect them, or and I will show one more thing as well. Suppose if you turn it on, yeah, as I said, and we have here point and the lattice is generated like that. So for each point we have, there is some wide space and around that wide, and it has a boundary. So like that our Voronoi lattice is generated. So if somebody wants to change the point spacing as a 5 mm, then one can see the difference of the Voronoi structure. See, there is a huge difference, isn't it, the compared to the previous and structure and the current structure. So this point spacing has a higher effect on the particular geometry, so be careful that how. So as per that, as per your requirement, you can use it accordingly. Let's go with the 3 mm point spacing, so we can have better Voronoi structure with the particular density. So okay, so yeah, one more thing I'm going to show you, that is like let's turn it on wall. What do we observe here? Huh? We have observed that there are some struts, they are out of boundary, isn't it? Boundary of given body. So how we can remove them, or they are not connected, as I said. Suppose this is not connected with this or this, they are free, isn't it? So if we want to connect them, so how can we connect them? So there is a one more option, that is boundary. So that's why this option is much more useful. So let's use this boundary. How can we define that boundary without knowing so let's double click there. So what are the parameter it is asking? So there are some parameters asking, isn't it? So for timing, I'm going to show you one more one. We are going to select only one thing, that is from mesh from implicit body. We can go with this. So if you want other things also, you can use them. But as I know that we can select this either mesh from cat body. For timing, we don't have cat body, so we have our implicit body as a cube. So we can go with this option. And again, what do we observe here? We have to define like we have to define some other parameters, like we have to define body and tolerance and minimum feature set. It is optional, but two major parameters, they are like body and tolerance. So let's place our body cube body within the body tab, and give the tolerance as like zero point 0.5, isn't it? So we have given the zero point 0.5. Now it started generating. So let's see what is going to happen. See, now there is a clear difference as compared to the previous structure and this structure. What is the difference? Now they are connected, earlier they are free. Now due to the mesh we have used, because of that, now each of the free links, free struts got connected, and we also observed that they are out of boundary. If you want to take them out, and if you want keep the struts within, and we don't want these outer struts, then you can use the trim lattice option. And we can use the trim lattice option, and we can remove those lattices, isn't it? So this is how we can play with all these parameters, and we can able to generate. I will show you exactly how it exactly looks. See, this is our cubic Voronoi lattice structure. If you want to generate the like Voronoi cylindrical Voronoi lattice, spherical Voronoi lattice, or any other volumetric Voronoi lattice, select the particular body and give the point spacing. It is up to you how much spacing you want to. So and give the particular thickness, so that you can tune the relative density or porosity of a given lattice. So okay, so this is how we can be able to generate the Voronoi lattice for a given body. Today we have selected our body as a cube, and we have selected a point spacing as a 3 mm, and we kept random seed as 1. Then we selected thickness, we have given thickness as 0.5 mm, isn't it? And then we also define the boundary. It is must, we have to give. This is the parameter we have to define, must and should, so that we can have better and well connected Voronoi structure. I will show one more thing as well, how to give the trim lattice, isn't it? So let's type the trim lattice. So what do we have? We have three options. Let's select the trim lattice, isn't it? We can place this trim lattice, yeah, here itself. And what are the parameters we need to define here? There are some parameters like lattice, which lattice we want to trim, and which domain we want to trim, and which what like which part you want to keep remain. So these are the things you have to define. Let's place our Voronoi lattice within the body, and also we can place our domain as cube. Let's place this cube as our domain, and let's to remain which one you want to remain. Inside one keep remain, outside we want to. So okay, and then define the feature thickness like point 1 mm. Let's see what is going to happen. Tolerance, not thickness. See, what do we observe? Our lattice or Voronoi lattice is inside only, and we are able to remove outer struts. Okay, so you can see now. So earlier there are some struts, some beams, some ligaments were outside. Now they are perfectly on the face and within the given domain, isn't it? So this is how we can able to define various parameter and various parameters to generate Voronoi lattice structures. So that's it for today. So what we have achieved today, we have achieved how to design how to design stochastic Voronoi lattice within a given volume. So in today's lecture, we have selected cube as our volume, and we have defined seed points like a seed spacing as a 3 mm. Then we have defined other parameter as well. First we have selected the steps involved, like we went to lattice tab, then thereafter stochastic lattice. From here we have selected the volume Voronoi lattice, isn't it? Voronoi volume lattice. There we have defined these three parameters like seed points. There we have selected the random points in body, and we have defined their respective parameters. Also define the thickness, and finally we have also trimmed, and we defined the boundary as well by selecting the mesh from implicit body, isn't it? Mesh from implicit body, we selected the body as a cube and given the tolerance respective, and then we connected each of the strut beams, and then finally we trimmed the lattice. So that's it for today. I hope you have learned something how to generate a stochastic lattice structure. Now you can do the other exercise. Uh, you can select the cylinder and then generate Voronoi lattice structure. That is homework for you. So it is up to you. You can do the iterations on other volume also as well, so that you can practice more and more, and you can learn this tool in topology. It has much more benefits. So up to this, thank you. Keep searching, keep sharing, keep shining. Thank you.